This is AP Calculus AB. We are on notes for 2-11, graph and table AP questions. Our objective today is to use graphs and tables to answer questions about the chain rule, product rule, and the quotient rule. All right, so first a review. What are those three rules that I mentioned in our objective? The chain rule, you probably have that one memorized. We don't call it that on our flashcard, and we really should. The chain rule is whenever you have f of g of x and you're trying to take its derivative. So you'll use this whenever you see a function inside another function. You can see down here that I see that there's a g of x inside of my f of x, therefore that is going to be a chain rule. It's really important to know your houses here, so if you see like a log house instead of a power house or something like that. So if I say f of g of x and maybe this is set equal to some other function, we'll say like h of x is defined like this. H of x is f of g of x, and that's usually how we see it. We say like h is equal to f of g of x. That's kind of the giveaway that you're going to be doing the chain rule. Then in order to find h prime, to find the derivative of h, we'll do like a little wavy sign here. That will be the outer times the dinner. So you can say that this is the outer, the derivative of the outer, times the inner, the dinner, the derivative of the inner. So the derivative of the outer is f prime of that outside, and you multiply this by the derivative of the inside, g prime of the inside. And just as a way to remember, whenever you're doing the doubter, this inner does not get touched. It's still g of x. You have to leave the inside alone. So you should make a note on that. Leave inside alone. You do not want to touch it when you're taking the derivative of the outside. All right, what about for our product rule? So usually product rule, we say it's 1d2 plus 2d1, and product rule is whenever you have a function multiplied by another function. So we'll say function multiplied, or I'll just say times because I'm lazy, times another function. And the quotient rule is when you have a function divided by another function. Whenever you have two sets of x's, usually it's going to be either product rule or quotient rule. When there's one x and it's kind of inside of an inside, that's usually a chain rule. So product rule, you're looking for two x's multiplied. Quotient rule, you're looking for two x's that are being divided. Usually what we say here, and I can make these rules a little bit more specific. I know I'm moving things over and that's cheating a little bit, but you can say if I have function 1 times function 2, and I'm trying to take the derivative, so maybe I can say this is equal to, we'll call this f, sure, why not? We'll say that this is f of x is equal to a function 1 times function 2. Then you can say f prime of x will be equal to that 1d2 plus 2d1. The main thing that you need to know is, as long as you know the 1d2 plus 2d1, you're ready to go. What if I say that my function is some fraction? So you have the top of the fraction divided by the bottom of the fraction. Usually we call that high and low. Then you can say to find the derivative, you do low d high minus high d low, and that's all going to be divided by low or low squared. All right, so we have all of our rules out of the way, and let's apply it to some examples. All right, so I have one example of a table. I consider table questions to be easier, and then you have two examples where we have graphs, and those I consider to be a little bit harder because they require you to do an extra amount of math. So every single time that you see one of these, you always want to start with your definition of what it means to do a chain rule or a product rule or a quotient rule. Let that definition guide you along the process. So in this case, I'm seeing that it explains, there's things in a table. Here's how we define our new function h. H is defined as g inside of f, and we want to take the derivative of h prime. And then once I take the derivative, I will be plugging in 1. That's essentially what this is asking us to do. So I will start with my definition. When I take h of x and I turn it to h prime of x, when I take the derivative, that means I'm going to have the derivative of the outside, so it's going to be f prime, and then I'm going to multiply that by the derivative of the inside. It's always doubter times dinner. So dinner here is g prime of x. And once again, we don't touch the inside. We leave that g of x. So now that I know the definition of our chain rule, I'm going to plug in 1 into this x, which means this x is also 1 and this x is also 1. So let me go ahead and write that out. I'm being overly enthusiastic with my notes here. You wouldn't normally show all this work. What I probably would have done right from the get-go is plug in 1 right away instead of leaving it in terms of x, but I like to go nice and slow for the notes, right? So this is going to be equal to f prime of g of 1 times g prime of 1. Again, all the x's get replaced with 1s. So I have a table here that says, hey, if you plug x is equal to 1, you can find what g of 1 is. So let's look for g of 1. So g of 1 means I'm talking about this g, not g prime, not f of f prime, not f. So I'm talking about g, and I go g of 1, so that intersects down here at 3. So I can say, okay, that whole thing is 3. So I can say g prime 1, you have to copy this down over and over again, is equal to f prime of not g of 1, but 3. I have swapped that out. And I'm going to multiply that by, okay, I need to find g prime of 1. Well, g prime is right there, and to find of 1 means g prime of 1 intersect over here at -2. So I can say that is going to be -2. And the only thing I need to find now is, what is f prime of 3? So I can say, okay, f prime is talking about this f prime right here. F prime of 3, that intersection comes down here at 7. So I can come down here and say this whole thing is 7, and then this can be multiplied by -2. So I have h prime of 1 is equal to all of that. And hey, 7 times -2 is a -14, which indeed is our final answer. All right, let's try a slightly harder example. This time you're asked to find f being multiplied by g, and we're going to take the derivative again. So when I take the derivative of two functions multiplied by one another, you have to go to your definition. Your definition is 1 d2 plus 2 d1. All right, so 1 is f, so I'll just say f of x. And then this is going to be multiplied by d2. The derivative of 2 is g prime of x. And then I'm going to do a plus sign. 2 is g of x, so I'll just write g of x. And this is going to be multiplied by the derivative of 1. The derivative of the first function is f prime of x. Prime of x. So this whole thing is our derivative, and I realize I'm kind of moving over a little bit. So I can say that this h prime of x, we have the derivative, and now that I have the derivative, I want to plug in 3 into my derivative. So now I'm going to say this is h prime of 3 is equal to, and then I'm just swapping out every single one of these 4 x's turns into a 3. So this is going to be f of 3 times g prime of 3 plus g of 3 times f prime of 3. All right, now I need to go on a scavenger hunt and find what these values are. So let's start with f of 3. Whenever you have f with no prime, that's just talking about the height at 3 on the function f. So first of all, f is right here, which is talking about this line. So it's asking the height at 3. So I go to 3, I say, okay, what height do I come up to? Oh, I go to that height, which is 4. So I can come over here and say this whole thing evaluates as 4. I can rewrite all this h prime of 3 business over here on the left is equal to 4 times, okay, I need to find g prime of 3. Okay, so whenever I'm talking about g prime, that's talking about the slope at 3 as opposed to the height at 3. So I'm looking at g first. So there's g. It's talking about this line right here. For on that line, I want the slope at 3. So I come up here to 3 and say, okay, at this point, what is the slope? And this is where we're going to do a little bit of legwork. We're going to say, okay, this is going right 1 up 2, right 1 up 2, right 1 up 2, right 1 up 2. Okay, so I happen to know, and I'll do this scratch work over here. In general, slope is defined as the change in y divided by the change in x. My change in y, I was going up 2, a positive 2, and I was going to the right 1. 2 divided by 1 is 2, therefore this whole slope here is 2. You are turning into 2. Plus, okay, now I have to find g of 3. Notice there's no prime, therefore this is just the height at 3. So I come over here and I look, okay, there's g, and I look at the height, or I go to the x-coordinate 3, I come up and I look at the height, there's my height. My height is 3. It just happened to be the same value, and I was lucky. And then I'm going to say this is going to be multiplied by f prime of 3. So f prime, again, is talking about a slope. So I'm going to come over to my graph of f. This is my graph of f. And the slope at 3, the slope at this one point for the x-coordinate of 3 is what slope? Well, in this slope, I'll do this in a different color. This slope is going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, over and over again. So it's going down 1, right 1, down 1, right 1. So this is slope, or this one's slope. Let me come over here, and I don't know if I can squeeze it in. Okay, here's some more room. I can say that the slope over here is going to be, again, the change of y over the change in x. Y was going down 1, x was going right 1. When I divide those two, I get -1. Therefore, this slope is -1, so times -1. I don't know why this 2 is randomly in red. I'm going to switch it back to blue. Hopefully that was still the same value. And then I just do the math, right? I can say now I have h prime of 3 is equal to, let's see, 4 times 2 is going to be 8 plus, and then I say 3 times -1 is a -3, and I add together 8 and -3, and I get +5. So that's equal to a +5. Done and done. All right, last example for the notes. We have more graphs over here, and on those graphs, I need to find h prime of 4. So meaning I have to take the derivative, and oh look, I have a function divided by a function, therefore I'm going to use my definition of the quotient rule. So I will write out the quotient rule once again, and we'll fill into it. The quotient rule is low d high minus high times d low, and this is all going to be divided by low, or low squared. Okay, so when I'm doing this, I'm going to plug it in over here on the right. I'm worried I'm going to run out of room. So low is g of x. This is going to be multiplied by the derivative of the numerator. Derivative of numerator is f prime of x. Minus, okay, now I'm going to do high, which is just f of x with no derivative, just f of x, times d low. The derivative of the low is g prime of x. And this is all going to be divided by low. No derivative, just g of x twice. I'll say g of x, whatever that is, and then we take that whole thing and we take it to the power of 2. All right, so that is all h prime of 4. So I can come over here and maybe annotate a little bit better and say, what we just found right here, this is h prime of x. We haven't plugged in 4 yet. So in order to find 4, we're going to plug in 4 into the x, which means ux, and ux, all 5 of you are now a 4. So let's go ahead and write that out. I can say now I have h prime of 4 is equal to, it's going to be g of 4 times f prime of 4 minus f of 4 times g prime of 4. All of this divided by g of 4, and whatever that value is, we're going to square it. And I realize that my line here could have been a little bit better. So let me go ahead and make a straighter line. Ta-da! All right. We just need to find what each of these values is. And I'm going to, each of these values are, use correct grammar. Okay, so this is going to be h prime of 4 is equal to scavenger hunt time. G of 4 is a height because there's no prime. The height at 4 for the function g. The function g is this line right here. At 4, I come up to this height. Oh, there's the height. That height right here is a height of 1. So I can come over here and replace this with a 1 times. Okay, f prime of 4 is the slope of f at 4. So at 4, I come up to intersect my line f. So what is the slope of this entire line? Well, I'm going right 1, up 1, right 1, up 1, right 1, up 1. Hopefully you know this, but that slope is 1. If you didn't know that, here's some scratch work off to the side. I can say for that slope, it's going to be the change in y over the change in x. My change of y was going up 1. My change of x was going right 1. 1 divided by 1 is 1. Therefore, f prime of 4 is just 1. Nice and easy. Did you know 1 times 1 is 1? That'll be easy later, right? F of 4 is the height at 4. So on this function f right here, the height at 4 comes up to a height of, that's a height of 2 over here. Okay, so I can come over here and say that height is 2. And then I'm going to copy down the multiplication symbol. Now I need to do g prime of 4. That means the slope at 4 for g. So here's my function g at 4 right here. What is my slope? Well, I'm not going right 1, up 1 because I don't go through this lattice point. I'm going right 1, 2, up 1, 2, 3. I was looking for those lattice points where it goes through those crosshairs, right? And I'm going right 2, up 3. And those are the only 2 lattice points that I see. So I can say I'm going right 2, up 3. So that slope, let's do some scratch work. I can say the slope over here. The slope is always the change in y over the change in x. That slope is going right 2, so right 2, and it's going up 3, which is a slope of 3 halves, or 1.5, whatever you prefer. You can call this thing 1.5 if you want. So I'm going to say 2 times, I'm just going to say 3 halves. I like fractions more than decimals. And now that's the numerator. Let's do the denominator. The denominator, oh, g of 4. Didn't we just do that? G of 4 is that value right there. That value right there is 1, so I can just put that 1 down here, and then I'm going to square the 1, which is, you don't need to do, but okay, 1 squared is just 1, so I can kind of ignore the denominator, right? Dividing by 1 is the same thing as not having anything. So I realize, oh, I'm running out of room here. I'm going to go ahead and shrink ray this stuff down. Will it let me shrink ray things in a single dimension if I just grab you and... That didn't work. What if I think I have to shrink ray you like this. Okay, that's good enough. Okay, and I can come over here and say, okay, 1 times 1 is 1, and I'm going to do that minus sign, and then 2 times 3 halves, well, this is the same thing as 2 over 1 times 3 halves. Those 1 and 2 multiply, those 3 and 2 multiply, so we get 6 over 2, or if you want to do it more clever, you can say, those 2 and 2 cross cancel, leaving behind 3. But 6 divided by 2 is 3 as well. So you say 3, and that's all divided by 1, but that's silly to say, so I'm not going to say divide by 1. And 1 minus 3 is negative 2. So you can say the final answer here is negative 2. Definitely box it. You see how messy my work is. You don't know, like, is that the answer? Is that the answer? Is that the answer? Where is it? That's the answer. Go ahead and box it. And that does conclude the notes. So there are the completed notes for 2-11, graph and table AP questions for AP Calculus AP. Thank you for watching.